In this lecture, we will discuss how to calculate probabilities of a standard normal random variable. Recall that a standard normal random variable has mean zero and standard deviation. The bottom of the slide shows the standard normal curve. It has some properties. Firstly, the area under the standard normal curve is 1. In fact, this is the property for all continuous random variables. Secondly, the standard normal curve extends uh, indefinitely in both directions, approaching but never touching the horizontal axis. This means that a standard normal random variable can take a value of any real numbers. It can be positive, 0, or negative. However, the value of the density curve is always positive. No matter how small it is, it cannot be 0. The standard normal curve is symmetric about 0. It has one peak at its center 0 and decreases when we move away from 0. Almost all the area under the standard normal curve lies between -3 and 3. A standard normal table is a table like this one. The values in the table are probabilities. The row and the column determines the value of z. For example, what is the probability less than 1.23? Equivalently, what is the area to the left of z under the density curve? Notice that 1.23 equals 1.2 plus 0.03. In the normal table, we look for the row corresponding to 1.2 and look for the column corresponding to 0.03. This yields the value 0.8907 in the table. Therefore, the probability less than 1.23 is 0.8907. Let us repeat how to use this standard normal table. This table lists the probability less than z, or the area to the left of z under the standard normal curve. We first need to round z to the second decimal places. Use the portion of z up to the first decimal place to identify the row. Use the second decimal place to identify the column. The resulting value is the probability less than z, or the area to the left of z under the standard normal curve. Another usage of this standard normal table is to calculate the value of z if we know a probability. For example, what is the value of z such that the probability less than z is 0.8907? For this problem, we need to locate the value 0.8907 in the table, which is highlighted by red. The row is 1.2 and the column is 0.03. Then the value of z is their sum, or 1.2 plus 0.03 equals 1.23. So we can use the standard normal table in two different ways. Firstly, find probability for given z. Secondly, find z for given probability. Before proceeding, I want to mention that there are two different standard normal tables you can use. One is in the textbook, one is the one I created. I include one copy on Canvas. You can also download it at the following link. It looks like this one. The two standard normal tables are essentially the same. However, for my table, I added some shadow in rows, which makes the table easier to read. Let's check more examples. Firstly, what is the probability larger than 0.76? Notice that the probability on the normal table are just the probabilities less than a value. If we need the area to the right of a value, we need first find the area to the left of this value and then use 1 subtract this probability. We can do this because the total area under the normal curve is 1. We decompose 0.76 as 0.7 and 0.06. The first part has values up to the first decimal place, and the second part only contains the second decimal place. Use 0.7 to locate the row and use 0.06 to locate the column. The probability on the table is 0.7764. One subtracts this probability yields 0.2236. Then the probability larger than 0.76 is 0.2236. What is the probability between negative 0.68 and 1.82? In order to find this probability, we need to find the probability in the table corresponding to each of the values, and then calculate their difference. Recall, we have mentioned before that the probability between two values is the difference of the corresponding cumulative probability. The probability in the standard normal table is exactly cumulative probability. For negative 0.68, we can decompose it as negative 0.6 and 0.08. Use negative 0.6 to locate the row and use 0.08 to locate the column. The probability is 0.2483. For 1.82, we decompose it as 1.8 and 0.02. Use 1.8 to locate the row and use 0.02 to locate the column. The probability is 0.9656. The difference between these two probabilities is 0.9656 minus 0.2483 equals 0.7173. So far, we have seen different examples of calculating probabilities: less than a value, larger than a value, or between two values. These three examples should include all possible scenarios in practice. Here, we have another example of finding the value of z for a given probability. What is the value of z such that the area to the left of z is 0.04? According to what we have discussed before, we need to find the probability 0.04 in the standard normal table. However, no value 0.04 in the table. It may happen in practice because this table only contains a limited number of possible values and it is not exhaustive. If it happens, we simply find the closest value in the table. The closest value to 0.04 in the table is 0.0401. It corresponds to row negative 1.7 and column 0.05. Hence, we claim that z is approximately negative 1.75. We want to introduce a new notation called z-alpha. This symbol is used to denote the z-score such that the area to the right of z equals alpha. We will use this notation frequently later. Of course, the area to the left of the alpha is 1 minus alpha. Let's find the 0.025. By definition, the area to the right of this value is 0.025. The area to the left of this value is 1 minus 0.025 equals 0.975. Try to find the value 0.975 in the standard normal table. It corresponds to row 1.9 and column 0.06. Therefore, the 0.025 is 1.96. Now, let's find the 0.05. The probability to the left of this value is 1 minus 0.05 equals 0.95. Try to find the value 0.95 in the standard normal table. This time, we cannot find the exact value of 0.95. Of course, we can try to find the closest probability as demonstrated in the previous slide. However, we play a different trick. Notice that the value slightly smaller than 0.95 in the table is 0.9495, and the number slightly larger than 0.95 is 0.9505. The value 0.95 is exactly the average of these two values. Therefore, the corresponding z-score should be the average of their corresponding z-scores. 0.9495 corresponds to 1.64, and 0.9505 corresponds to 1.65. The average of 1.64 and 1.65 is 1.645. Therefore, the 0.05 equals 1.645. You may need to remember these two values. The 0.025 equals 1.96, and the 0.05 equals 1.645. We need to use these two values frequently later. Now, try to find two z-scores such that the area between these two z-scores is 0.95 and the area on both sides are 0.025. Clearly, the second z-score is exactly the 0.025. We have already known that this value is 1.96. By symmetry, the first z-score is negative 1.96. Of course, we can also verify this using the normal table. Try to find the value 0.025 in the normal table. It corresponds to the row negative 1.9 and column 0.06. Hence, the z-score is negative 1.96. We can calculate the probability or find the z-score using Excel. The function to find the area to the left of a value is norm.s.dist. Notice that we need to set the second argument of this function as true. The function to find the z-score corresponding to a probability is norm.s.inv. Let's revisit the examples we just discussed using the standard normal table. What is the probability less than 1.23? The corresponding Excel function is norm.s.dist 1.23 true. Notice that the second argument must be true. Excel will calculate the probability as 0.8907. What is the probability larger than 1.76? The Excel function is similar to the standard normal table in that it only gives us the probability less than a value. If we need the probability larger than a value, we need to use 1 minus the probability given by Excel. Here, I calculate the probability larger than 0.76 by 1 minus norm.s.dist 0.76 true. The answer is 0.2236. What is the probability between negative 0.68 and 1.82? We need to calculate the difference between the corresponding probabilities. Here, the correct Excel function is norm.s.dist 1.82 true minus norm.s.dist negative 0.68 true. The answer is 0.7173. What is the z-score such that the area to the left of z is 0.04? The Excel function is norm.s.inf 0.04. Excel can give us a more accurate answer, which is negative 1.7507. Using the standard normal table, we can only know that this number is approximately negative 1.75. If you want to find the alpha, you need to be very careful, because alpha means the area to the right. However, the input of the Excel function is the area to the left. Therefore, to calculate the 0.025, we need to use norm.s.inf 0.975, and the value is 1.96.